If the coordinates of the vertex and the focus of a parabola are at 3, 4 and 5, 4, then we need to determine the equation of this parabola. Let us begin. So here, we'll first consider a straight line, and on the straight line, we're going to consider 2 points. Let's say this particular point corresponds to the vertex of the parabola with coordinates 3, 4, and the other coordinate is going to be other point is going to have the coordinates 5, 4, which is going to represent the focus of the parabola. Now, we're going to consider a third point on the same line. Let this point be point A, having the coordinates A, B. Now, the point A is chosen in a very specific manner. It's chosen in such a way that its distance from the vertex, this distance is exactly equals to the distance of the focus from the same vertex. Now, that means, in other words, we can say that V is the midpoint of A and F. Since V is the midpoint of the line segment AF, we can easily find out the coordinates of point A. All we have to do is take the coordinates of the vertex, that's 3, 4. So this will be equivalent to, we'll take the sum of the x coordinates of point A and point F, or A added to 5 divided by 2. That will be the x coordinate of the vertex, and the y coordinate of the vertex will be b plus 4 divided by 2. So since they're equal to each other, we can equate them to get the value of A as equals to 1 and b value that will be equals to 4. So that means the coordinates of point A is going to be 1, 4. Now, by definition, any straight line on which the vertex and the focus of a parabola lie, that line is referred to as the axis of symmetry line. Now, clearly, we have the coordinates of the vertex and the focus lying on the axis of symmetry line. We can find out its equation as well as the slope of the line. So let's first begin by obtaining the slope of the axis of symmetry line. We're going to denote it by the letter M1. So here, the slope can be obtained by taking the ratio. In the numerator, we need the difference of the y coordinate, and in the denominator, we need the difference of the x coordinate. So here, in the numerator, let's take the focus minus the vertex. So we have 4 minus 4 divided by 5 minus 3, which gives us a value equals to 0. So that means the slope of the axis of symmetry line has 0, and we know any line that has a 0 slope, that line is going to be parallel to the x-axis. The reason why we obtained the slope of the symmetry line, because that will be helpful in finding out the equation of the directrix line. Now, the directrix line is going to pass through the point A, and it is going to be perpendicular to the axis of symmetry line. So that's the definition of a directrix line. So here we have the directrix, which is passing through the point A. A has the coordinates 1, 4, and we need to obtain its equation. That means to find out the equation of the directrix line, we'll be using the point slope form. Point slope form states that if we have a straight line passing through a point with coordinates x1, y1, and the slope of that line is known, then the equation of the line will be given by y minus y1 equals to the slope multiplied to x minus x1. So that means in our case, we already have the coordinates of point A. So this is the point through which the directrix line is passing, that's 1, 4. We need to find out the slope. Now, we can find out the slope of the directrix line. The slope of the directrix line, that's going to be undefined. The slope of the directrix line is undefined. The reason behind this is because the slope of the axis line is along the x-axis, and since the directrix line is perpendicular to the x-axis, that means it is actually parallel to the y-axis. And we know the slope of the slope of the line which is parallel to the y-axis is always undefined, and its equation, then the equation of this simply means that the equation of the directrix will be given by, we have a standard form for that. This equation of the directrix is given by x equals to the x coordinate of the point through which the directrix line passes. So in our case, that's 1. So that means the equation of the directrix line, that's going to be x equals to 1. So now we have the equation of the directrix line, we have the coordinates of the focus. Using only these two information, we can find out the equation of the parabola. So let us begin. So we have the directrix line given by x equals to 1. We have the axis of symmetry, on it lies the focus. The coordinates of the focus, that's 5, 4. Now to find out the equation of the parabola, we're going to consider a point on the plane, and P is going to have the coordinates x, y. P is referred to as the locus of the parabola, and the locus of the parabola by definition is chosen such that the distance PF is exactly equals to the perpendicular distance of the point P from the directrix line. That's why the perpendicular distance meets the directrix at M. So by definition, for a parabola, we can say that the length PF must be equals to PM. Now we can easily find out the length PF by using the distance formula. So here we'll take the square root. Underneath the square root, we take the difference of the x coordinate. So that's x minus 5. We square this value and add it to the difference of the y coordinate. So that's y minus 4. We square this value as well. This will be equals to PM. So PM is the perpendicular distance of the point P from the straight line x equals to 1. Now there is a standard formula for finding out the perpendicular distance. Let's say we have a point with coordinates x1, y1, and then we have a straight line with the equation ax plus by plus c equals to 0. If we drop a perpendicular from that point on the straight line, then this perpendicular distance can be obtained by using the formula. All you have to do is take the absolute value. In the absolute value, we have to take a ratio. So here we'll take the coefficient of x of the straight line. So that's a gets multiplied to the x coordinate of that point. So that's x1. This will be added to coefficient of y, that's b, multiplied to the y coordinate of that point, so y1, plus the constant term c, divided by the square root of, now here we have to take the sum of the squares of the coefficient of x and y. That means we have a squared plus b squared. Now what we'll do, we'll try to rewrite the equation of the directrix x equals to 1 in the general form of a line ax plus by plus c equals to 0. So here we have x minus 1 equals to 0. This can be also expressed as 1 multiplied to x. There is no y terms, but what we can do, we can rewrite it as 0 times y minus 1 equals to 0. So we have here a corresponding to 1 and b corresponding to 0. So that means the perpendicular distance is going to be given by, we have a times x1 is x here, plus b times y, when we have negative 1, that's the value of c, divided with by the square root of 1 squared plus 0 squared. Fine. So we're going to get the square root of x minus 5 whole squared plus y minus 4 whole squared equals to the absolute value of x minus 1. So here we can square both sides to get x minus 5 whole squared plus y minus 4 whole squared equals to x minus 1 whole squared. So let's expand x minus 5 whole squared. We are going to get x squared minus 10x plus 25. Expanding y minus 4 whole squared, we get y squared minus 8y plus 16. So this will be equals to x squared minus 2x plus 1. So here we can cancel out x squared from both sides. Now we have y squared. Then we have negative 10x. So we'll transpose negative 2x to the right hand side to make it positive 2x. So negative 10x plus 2x, that will be negative 8x. So y squared is done. Then we have negative 8y. Then we have 25 plus 16, that's 41. 41 minus 1, that will be positive 40. So this will be equals to 0. And this is the required equation of the parabola.